There's a dual LP. And that dual is going to do a maximum instead of a minimum. And the cost is going to involve the B from the primal problem. So this is now called the primal problem, and this is its dual. So they're twin problems. They use the same data, but quite differently. It's like transposing things. So let's call the unknown y. So for y1 to ym, I guess, because b, the right-hand side over here, is m by 1. So that's maximize that subject to what are the constraints. Well, the cost function over here, c, the cost vector, goes into the constraints. And I think the greater or equal sign probably becomes a less or equal to sign. The a gets transposed. I think that's probably the constraint in the dual. And it happens it doesn't need y. We don't have y greater or equal to 0 over here. Okay, so that's a dual problem. It has linear cost. It has linear inequality constraints. It can be solved by the simplex method. You could choose whether you solve that one or this one, because if you solve one, you solve the other. The two are closely connected, and that's the key idea of duality. So maybe I'll put the idea of first of all, of weak duality.